Alright, welcome to Lab 2 for Physics 2212. My name's Raquel May. Let's jump right into it. So the introduction to the lab. The idea of the lab is to take what we learned in Lab 1 and use that to create a computational model that can elevate how we understand the two charged tapes. The purpose of the lab is to compare the results from Lab 1 from the point charge model and create a more accurate linear charge model. We'll be doing this by dividing the line charge into multiple points and then using GlowScript's code to simulate the line charge. So preview, using the point charge model, the charge on each tape was 1.65 times 10 to the negative 8 coulombs. This was from Lab 1. And then now using the linear charge model, our charge was 4.74 times 10 to the negative 8 coulombs. And so the three fundamental concepts that we'll be using for this lab. We start with Newton's second law. An object's acceleration is directly related to net force and is inversely related to its mass. That's that first equation there on the top right. Then Coulomb's law, it just describes the amount of force between two electrically charged objects at rest. That's the one in the middle right. And then the gravitational force equation. This relates to the force between any two given objects with mass. That's the bottom right there. And so going back to Lab 1, our results from that experiment, we had the tape mass equal to 4 times 10 to the negative 4 kilograms. The tape length was 0.4 meters, and the tape width was 0.02 meters. The tape distance was 0.025 meters. And then here on the left, you can see the blue point charge that represents the top tape, and the red point charge that represents the bottom tape. And then you have the green arrow of the electrical force, and then the orange arrow is the gravitational force. And yeah, and there at the bottom you can also see that the charge on each tape was in fact 1.65076 to the negative 8 coulombs. And so going into Lab 2, we just used the same gravitational force from Lab 1. The gravitational force on tape B was 3.924 times 10 to the negative 3 newtons. And so this is equal to electrical force on tape B, since they're equal just in opposite directions. And so that gives us again 3.924 times 10 to the negative 3 newtons. And then using an electrical force on a rod, we can get the electrical charge Q equals 4.74 times 10 to the negative 8 coulombs. And we're using this electrical force of a rod since the tape can be represented as a linear segment of multiple charges, similar to how a rod acts. And so that gives us Q. So computational model, the constants were gravity, mass, and then the tape length and the distance, of course. So here we have the electric field function. This is just what we use using the observation location, the charged particle position, just to give us an idea of how the electrical field on tape B acts. And here we have the line charge function. Here we're basically just dividing up the tapes into multiple segments to give us an idea of how the electrical force acts on those individual segments. And then we have to use superposition to sort of nest, using a for loop, all the different points that we're calculating the electrical field for. And here we have the results. The green represents the electric field, and then we have the white arrow that represents the vector for the electrical force. The yellow arrow represents the vector for the gravitational force, which is equal to the white arrow, just again in opposite direction. Then we have the two tapes in blue and red. And so the assumptions we had to make, air resistance and friction were assumed to be negligible. The tape segments were assumed to be equal in charge. And finally, each segment of tape had the same amount of evenly distributed charge. These were all the things we had to assume. Errors, potential errors I should say, were the loss of charge that could result from the handling of the tape, the unequal distribution of charges in the segments of tape, and the inaccurate measurements or potential inaccurate measurements during the experimentation. And then lastly, the what if and why. What if you had modeled each of your tapes as a single point charge? Well, we did that in the previous lab. Here we have the point charge of that, which was 1.65 times 10 to the negative 8. And then how does that compare to linear charge? Well, the linear charge was greater at 4.74 times 10 to the negative 8 coulombs. But why do these differ? Well, the two calculations differ since there were different levels of precision and accuracy. Since the line charge uses segments and treats the tape as a single line instead of a single point, then you have something that becomes more accurate. And that's all. Thank you for watching.